Pythagorean theorem is one of my favorite math topics. The Pythagorean theorem deals with a right triangle. It's not true for anything else. We have to have a right triangle. It says that if you take your two legs, we call them A and B, and you square it, A squared plus B squared is equal to C squared. And C is always the hypotenuse. The hypotenuse is going to be our longest side, and it's always going to be across from our right angle. So directly across from the right angle. The reason I like the Pythagorean theorem is because it has so many really neat proofs. And I provided a link for you guys to watch it being proved with starburst and then also being proved by using water. Both of these have to do with the area, and they turn this triangle and they make it into squares because this is an A square and a B square. So a square with sides length A and a square with sides length B is equal to a square with sides length C. What's also really neat about the Pythagorean theorem is it is the only math theorem that's been proven by a U.S. president. President Garfield proved the Pythagorean theorem. He used the area of trapezoids instead of squares back before he became president when he was in the Senate. And he's the only president to ever prove a math theorem. So I think that's really neat. Let's look at some problems. First, we have this shape over here. We're trying to find this missing distance. Now, the Pythagorean theorem is only good for right triangles. It's not good for this trapezoid here. So I'm going to have to make a triangle. So what I need to remember is this distance down at the bottom is the same as the distance at the top of the square. So I'm going to call this distance. And now I have this nice triangle here. My hypotenuse is 14 meters. I'm looking for my distance. So I need to figure out this missing piece right here. I know the whole length is 25 and just the square is 15. So that means this missing length is 10. So I'm going to plug those numbers in. Again, the hypotenuse is 14. That's the diagonal, the one across from this right angle. I just found 10 and I'm looking for the distance. I'm going to square those. So doing some calculations, 14 squared is 196. 10 squared is 100. I'm going to subtract 100 from both sides to get d squared is equal to 96. Now, I don't need d squared, I need d. So the opposite of a square is a square root. So I'm going to take the square root of both sides. Now, I cannot leave my answer like that. I need to reduce my square roots. I've put up my video that reminds you of how to do this. This is a topic in our previous class into Math 201. But just a quick reminder, I'm going to make a factor tree. It doesn't matter how you start your factor tree. We're all going to get down to the same prime factors. And I pull out pairs. So a pair of 2's and a pair of 2's. So two pairs of 2's. Each pair is only written one time. Here's one pair of 2's. There's the other pair of 2's. And then everything else gets thrown back underneath the square root. So I get 4 square roots of 6 when I multiply. And this is in meters. We've already looked at area, so sometimes we're solving for meters squared, but our Pythagorean theorem is only just finding a distance, so that's plain meters. Now you need to watch the directions on my math lab. If they ask for an exact answer, they're looking for 4 square roots from 6. If they ask for you to round to the nearest hundredth place or to the nearest meter, if they ask anything about rounding, then you're going to type this in your calculator and then round to whatever directions they give you. Now for our quizzes and exams, I don't want to have to go back and forth. So I'm always going to ask you to give me the exact answer. So you're always going to give me the reduced square root answer for anything in class. Now my math lab, just watch. If they want rounding, type in your calculator and round. If they want exact, stop at the square root. Let's look at another problem. This one doesn't have us finding a missing piece. It wants to know if these three numbers can make a right triangle. Now remember, the hypotenuse is always my largest number. So 42 is what I'm going to plug in for C. So I'm basically just seeing is 24 squared plus 32 squared equal to 42 squared. So I'm going to plug and chug. Plug these in my calculator. They do not equal 42 squared because 42 squared is 1,764. So the answer to this is no. If I plug these two numbers in and it equaled 1,764, the answer would be yes. Let's go back to another problem where we're looking to find a missing piece. This one does not have the picture given. Now you don't have to draw the picture, but sometimes that helps people. So I did draw the picture. We've got this ladder leading against a wall. Ladders and ramps are always the hypotenuse. They're always diagonal. They're always across from the right angle. So here's my 15-foot ladder. There's my right angle. And then my 15-foot ladder starts 3 feet from the wall. So here's my wall. My ladder's ending at 3 feet away, and there's my ladder. If you had put the 3 on the other side, it wouldn't have changed the problem. Basically, the only thing that matters is picking out the correct hypotenuse. The legs are interchangeable. Okay, so I'm looking for this missing piece right here. So I'm going to plug in 15 for my hypotenuse and 3 for my leg. Type these in my calculator. I'm going to subtract 9 from both sides to get 216. Again, I need to take the square root. And then I have to reduce that square root down using my factor tree like I did before. So when I reduce it down, I'm going to end up with a pair of 3s, a pair of 2s, and then a 3 and a 2 left over to give me 6 square roots of 6. And again, my units are just plain feet.